today we are going to discuss about the second part of our previous discussion, which was the exponential function. But today I will give you a specific or a special case of the general exponential function. So we recall that the general formula for the exponential function is given by f of x is equal to b raised to x, where b is positive constant and x is the exponent. Now, b is what we call the base of the exponential function. Now, we have here a special case for the general exponential function, and that is if our b is equal to our e. It's equal to e, and e is approximately equal to 2.71828, and e is also called as the Euler's number. Okay? Now, the function f of x, where base is e, is what we call the natural exponential function. Okay? So, let us look at the graph of the natural exponential function. It passes through the point 0, 1, okay? And it has a domain, which is set of real numbers and range 0 to positive infinity. Okay, so suppose we are given the function y is equal to 2 raised to x and y is equal to 3 raised to x. Okay, let us try to compare the graph of e raised to x. What have you noticed? Okay, we recall in our previous discussion that as b increases, okay, the graph of the exponential function approaches to the y-axis. So since the Euler's number is approximately equal to 2.71828, so we expect that the graph of e raised to x is in between, okay, the graph of y is equal to 2 raised to x and y is equal to 3 raised to x. Okay? Because 2.71828 is greater than 2, but lesser than 3. Okay? So that's the graph of the natural exponential function. So this time, we have here the laws of exponents, because these laws are very important when we evaluate an exponential function or we solve an exponential function. So let us review first on the laws of exponents. So if a and b are positive numbers and x and y are any real numbers, okay, so since by definition of exponential function, the base of the exponential function is positive. So suppose we have a and b be positive numbers and x and y be any real numbers. So the first law says that b, which is the base, raised to x plus y is just equal to b raised to x times b raised to y. Okay? So take note of that. Number 2, b raised to x minus y. So if it is subtraction, this is equal to b raised to x over b raised to y. Okay? Number 3, if we have quantity b raised to x raised to y, this is just equal to b raised to x times y. And number 4, quantity a times b raised to x is equal to a raised to x times b raised to x. Okay? So again, you get a piece of paper, then you list down all of these laws of exponents for you to remember all of this. So we have here examples as an application to the laws of exponent that we have earlier. For example, the first law, that is b raised to x plus y is equal to b raised to x times b raised to y, right? So if we have b, which is 2, and x is equal to 3, and y is equal to 2, so we have 2 raised to 3 plus 2 is just equal to 2 raised to 3 times 2 raised to 2. Okay? Now take note that 3 plus 2 is 5, so we have 2 raised to 5 is equal to 2 raised to 3 is 8. So 8. 2 times raised to 2 is equal to 4. Now take note that 2 raised to 5 is equal to 32 and 8 times 4 is 32. Number 2 property, 2 raised to 3 minus 2. Okay, this is taken from the formula that we have, b raised to x minus y is equal to b raised to x over b raised to y. So this is 2 raised to 3 minus 2 is equal to 2 raised to 3 over 2 raised to 2. Now 2 raised to 3 minus 1 is 1, 2 raised to 1 is 2, 2 raised to 3 is 8, divided by 2 raised to 4 is 4. Then this is 2 is equal to 2. Okay. Number 3, we have the property b raised to x or quantity b raised to x raised to 2 is equal to b raised to x times 2. Okay. Now, take note that 2 raised to 3 is equal to what? Or by applying this formula, this is equal to 2 raised to 3 times 2. Okay? This is 2 raised to 6, which is equal to 2 raised to 6. Or in other words, first you have to solve 2 cubed, which is equal to 8, right? Then 8 squared is equal to 64. And this is also 64. Number 4, we have quantity a times b raised to x is equal to a raised to x times b raised to x. Since we have our a, which is 2, multiplied to 6, so we have what? 12 squared. We have 12 squared is equal to 4 times, this is 4 times 36. Then the answer is 144. Okay? So these are the examples on the laws of exponents. So all we have to do is just to familiarize. And again, we can familiarize all the formulas, not all. Most of them, you can familiarize it by practicing. So you have to practice always in mathematics. Okay, thank you so much. Hope you like this video and don't forget to share the learning that you've got from this video. Once again, thank you very much.